So hello everyone. So today we are here to discuss about a project that is cryptocurrency analysis and forecasting using LSTM and Facebook Prophet model. So before starting with the project, let's look at what cryptocurrency is and what it means. So a cryptocurrency or crypto is nothing but a digital currency that can be used to buy goods and services online, and it uses an online distributed ledger with strong cryptography to secure the online transaction. So why people use cryptocurrency? So basically, cryptocurrency has no intrinsic value, no physical form, and its supply is not determined by the central bank. That is, network is completely decentralized. So first of all, let's start with importing all the necessary libraries, that is NumPy, Pandas, and Plotly for performing EDA or exploratory data analysis. So all the required files are inside the input folder, and let's see what all files we are using. So this is the list of files that we are going to use, and let's combine this file into a master data frame and look what the columns of that data frame are. So here is our master data frame. It has following column like name, symbol, date, high, low, open, close, volume, market cap. Now let's see what these column means. So date means the date of observation. Open is the opening price in a given day. High is the highest price of a particular Bitcoin on a given day. Low is the lowest price. Close is the closing price. Volume is the volume of transaction on the given day, and market cap is market capitalization in US dollars. So let's start. Let's start our EDA. So first of all, what we are going to do is we are going to group by the data using name and then calculate the mean for each and every data set. So first of all, let's start with understanding what correlation is. So correlation is a statistical measure that expresses the extent to which two variables are linearly related to each other. So in the graph below you can see the positive correlation, the negative correlation, and no correlation at all. So we are going to see the correlation between the top 4 Bitcoin that are majorly used, that is Bitcoin, Ethereum, Ripple, and Litecoin. So we are going to plot a heat map that is going to show the correlation between top 4 cryptocurrency using Seaborn. So here is our cryptocurrency correlation map, and as you can see, the value with brightest color is the highest correlation, and with darkest color is a negative correlation. So now let's see or start analyzing our dataset, and for that we are going to use Plotly, and this is the graph that we plot between market capitalization, cryptocurrency, and dates. Hope you are able to see it. So as you can see, the Bitcoin has the largest capitalization, that is around 1T, and the second is Ethereum. So this is a brief comparison about the top 5 cryptocurrencies. So first of all, let's start by choosing Bitcoin as the source of prediction, as it is the most popular and most used one. So first of all, we are going to use a bidirectional LSTM to forecast the price of Bitcoin. So let's start with importing the CSV file and then dropping all the unnecessary columns. Now here is a view or a description of our dataset. So we have a total count of 2,862 columns. So first of all, let's convert the date into a date time format using Pandas. Then let's set the date to index and see what volume and market cap, what inside volume and market cap gives us. So here you can see that between year 2020 and 21 we have the most spike in both volume and market capitalization. So now let's define a model and start importing all the necessary libraries to create a model. So the two main libraries are TensorFlow and Keras. So here we have imported all the necessary libraries including TensorFlow and Keras. So here is the shape of a dataset, that is it has 2000 records and it has 7 columns. So let's see. So we are going to predict the closing price of a particular Bitcoin on a particular day. So first of all, let's analyze and see what these closing price are and how it varies in our dataset. So our dataset is started from 2015, and you can clearly see a little bit of spike in 2017 and 2018, and a very large spike after 2020. So let's start our analysis. So first of all, we are going to use feature scaling, and firstly we are going to normalize our data and all the numerical values, and we will scale these values in range of 0 or 0, 1 and -1, 1. So we are doing the same, and we are going to use min-max scaler for that. And after scaling these values, we are going to feed these values to our model, but it is not that easy. So feeding values in LSTM can be tricky, and for that we are going to need a concept that is known as windowing. So here is how we are going to prepare our data. So we will use a concept named as windowing. So as you can see in this figure below, we have an input width of 6 and an offset of 1. So that means that we are going to use t0, 2 and 2, t equals to 2, t equals to 3 and t equals to 4 and t equals to 5 for our training, and t equals to 6 for prediction. So here in the figure below, you can clearly see that these are our input t0 to t5, and the t6 is the label for our prediction. So this is how we are going to model, or this is how we are going to feed the data to a model. So let's make sequence length of 100. That is basically we are going to see 100 past date to predict one future date. So let's start building a model. So firstly, let's split our data into X-train, Y-train, X-test and Y-test. So we are going to split our data, and for that we are going to use the train split value as 95%. So here you can see the shape of train and test. So before going any further, let's discuss what LSTM is. So LSTM, or long short-term memory network, are a type of recurrent neural network that are capable of learning order and dependency in sequence prediction problem. So LSTM has a chain structure that contains 4 neural network and different memory block called cells. So let's start building a model. So firstly, we are going to create a model. So our model is going to have a dropout of 10. So there is no overfitting. So we are going to take care of overfitting as well. So firstly, we have first layer, that is a LSTM layer with an output shape of 128. Then we have an activation function, that is leaky ReLU, and we have tuned the parameter to 0.5. Then we have another LSTM with return sequence true. So both of our LSTM layer will take an input in forward direction and backward direction too. So after every layer, we are also adding a dropout that will automatically just shut 30 neurons, 30% neurons in a network. So we have a last LSTM layer with return sequence false. That means we are not going to see the data in backward direction. Then we are using a dense layer to predict or to forecast the prices. So here we will compile a model, and we are going to use loss as mean square error and optimizer as Adam. We are going to load the data in a batch size of 64, and we are going to perform total 50 epochs. So as you can see that we have our loss, training loss and validation loss for each epoch. So after some time, let's see or evaluate the graph. So the total loss of our model is around 0.008. That is pretty low. And let's see the plot of training and testing. So as you can see, in the beginning there is a lot of difference between our training and testing dataset, and in last all this loss converges. So now let's predict the values and see what is our prediction for next 100 days. So here is the graph showing the same. So here the red lines indicates the predicted price, and the green line indicates the actual price. So this brings an end to the LSTM model, and now let's try the same dataset with Facebook Prophet model. So let's understand. So now we are going to use Facebook Prophet model to predict the closing price of Bitcoin. So Facebook Prophet model was developed using an open source library known as Prophet, and this library is available for both Python and R. So it is really fast, and it is built in on top of Stan, that is a programming language that is written in C++. It is an additive regressive model which has non-linear trends and is able to fit weekly, yearly, and also check the seasonality of the data. So it uses piecewise linear or logistic growth curve, and Prophet automatically detects the change in trends by selecting the change points from the given data. So weekly seasonal data is measured using a dummy variable, and seasonal component is measured using Fourier series. So the model uses a decomposable time series model with three major components, that is trend, seasonality, and holidays. So here in the below equation you can see all these variables: GT as the piecewise growth, HT as the progressive or the effect of holidays on our dataset, and ST as the periodic changes, and ET is the error terms that we are going to account for. So let's start with reading the CSV file and plotting the basic graph. So let's convert the date into pd.datetime format, and let's just import the Facebook Prophet model. So here we are going to first initialize our Facebook Prophet model and see what columns we have in a dataset. Then we are going to drop all the null values and rename our column as DS and DU, as DS and Y. As in Facebook Prophet model, we have to use the column name as DS and Y. Then let's see the head and the tail of the dataset, and you can see we're having the tail as 2021 412. So we have the latest dataset. So then using model.fit, we are going to train our model, and let's see and predict the data and predict the future date with a period of 300, that is for future 300 days. So this is our dataset for future 300 days, and let's predict. So here is the prediction that we generated using Facebook Prophet model, and here is the y hat or the prices for each day. Now let's plot this prediction and see what results we have. So you can see all these black points or the black dots are the actual data, and the blue line is our prediction that we have predicted using Facebook Prophet model. So you can see that the prediction is pretty much accurate. So now let's plot and see what is our trend and the weekly and seasonal trend of the data. So you can see the trend. So you can see the trend is after between 2021 the price of Bitcoin is growing fairly high, and in weekly we can see that the data is at top in Mondays and Fridays, and yearly we can see a high between March and May and a low between September and the month of November. So this is all from my side, and I will provide the link of the code in below section. Thank you.